question says to graph the rational function y equals 2x minus 8 over x plus 4. So we're going to have to break this down into its simplest components and basically go and plot everything that we can find of significance. The first thing for a rational function, obviously, you've got some information at the bottom, and we know that the bottom gives us the values for the vertical asymptote or the restrictions on the function, because we're not allowed to divide by 0, so any value that would result in a 0 at the bottom are where the vertical asymptotes lie. In this case, this is pretty easy to see. If x was negative 4, then negative 4 plus 4 would be 0. And so we've got that vertical asymptote at roughly negative 4. In addition, if we look at the top portion gives us our x-intercepts. And so whatever value makes the top part equal to 0 is the x-intercept. 2 times 4 is 8, take away 8 gives us a value of 0. So we also have an x-intercept, therefore add positive 4. And I can put these values in for us. So there's the 4. And we'll also create one for the vertical asymptote at minus 4. Now, when we make all the x's equal to 0, remember that's when we find our y-intercept. So if x is 0, this 2x and the single x are going to go away, and we're left with simply y equals negative 8 over 4, which is the value negative 2. So we know that our y-intercept is at minus 2. Quicker to just sketch that in there. The last thing we have with this ax plus b over cx plus d kind of function is we're going to have a horizontal asymptote, but the horizontal asymptote moves away from the x-axis. It's not at 0. So to find the value, we go find the highest degree terms, which are these two x's, and we compare their coefficients to each other. We've got 2x over 1x. So we look at just the coefficients. 2 over 1 is 2. That tells us that we will have a horizontal asymptote at 2. This is also a linear function over a linear function. So this graph will look like a linear reciprocal. So we're just going to have the two single arms on each side, except for that fact that our horizontal asymptote has moved away from the x-axis. But because we've already plotted a couple of points, we know our graph must pass through those points. It's fairly simple for us to see that the rest of the graph is therefore, we'll have an arm down here, and it approaches the vertical asymptote there, and then we'll also have another arm on the opposite corner, which looks like that. So there's the graph for this function.